Hello, my name is Jakob Kather. I'm the co-chair of the ESMO Real-World Data and Digital Oncology Group. And with me I have Dr. Mihaela Aldea. She's an oncologist from Gustave Roussy in France. Together we were part of the ESMO Basic Requirements for AI-based Biomarkers in Oncology project team, and we're super happy to present some of this work here today. So the EBAI framework is the result of a project group within ESMO that was aiming to bring some guidance to the field of AI-based biomarkers. Biomarkers help us to prescribe the right treatments to the right cancer patients, and there's many experimental assays available to measure these biomarkers. What we are seeing is that now increasingly artificial intelligence is being used to measure such biomarkers, and there's hundreds of papers and dozens of products out there where people use this. The problem is that there's no conceptual framework and no guidance on how to validate and how to use these biomarkers, and this is precisely what we try to do within our EBAI group. EBAI stands for ESMO Basic Requirements for AI-based Biomarkers in Oncology and is the result of an interdisciplinary project group that has currently concluded its work and is wrapping up the EBAI project.
We have classified AI biomarkers in three classes. Class A is the quantification of the biomarker by AI. And here, as an example, we have the PD-L1 quantification automatically from immunohistochemistry slides. And here, the input is the same that a human operator will use. The method is new because it's based on AI, but the output is also similar to what the human operator is actually obtaining. Class B is the prediction, the approximation of an existing biomarker. Here the example is the prediction of EGFR mutations from hematoxin-eosin. The input is different because we are not using NGS, we are using the hematoxin-eosin tissue slide. The method is different because it's AI-based, but the result is the same. It's the EGFR prediction status. And we have a third class, which is the class C, predictive biomarkers, where we can predict either the prognosis, either the treatment response with these biomarkers. And here everything is new, the input, the method, and the output. And as example, we can have the prediction of immunotherapy outcomes starting from multimodal data or digital pathology data or radiomic data.
So the way we approach this guidance document, EBAI, is very similar to any other guidance document that is developed in ESMO. First, we assembled an interdisciplinary group of experts representing diverse sets of viewpoints from the ESMO family and beyond, and we will hear more about this in a second, I think. And then we had an exploratory phase where we collected all the evidence, all the different perspectives. We synthesized this into statements that are clear and provide specific guidance, and then we had a multi-step Delphi procedure with predefined criteria to vote on these to provide a consensus-based guidance for the community.
This was a collaborative work between two ESMO task forces, the ESMO Precision Medicine and the ESMO Real-World Data and Digital Oncology Task Force. We have invited also experts that were not necessarily were part of these task forces, and there were experts from different domains of oncology, including medical oncologists, radiologists, pathologists. And we have also invited computer scientists, one patient advocate, biostatistician and a statistician, and also individuals with expertise in regulatory approvals.
So we think that the oncology community will increasingly adopt AI-based biomarkers. It's clear that AI methods are permeating many aspects of oncology, including biomarker development and use. And we are seeing actually more and more evidence coming out where these types of biomarkers are even validated in studies. there is some legal and regulatory guidance for these types of AI systems. For example, in the European Union, many of them are classified as medical devices. But we think that we need a community effort to provide more guidance that exceeds basically the standards that are set by the regulators, that provide us with a framework to understand what are these biomarkers about and what are their risk classes. And I want to give one example. If you have a biomarker that just measures one biological property that you can usually measure with many other methods, you just have a new method to measure the same thing, then probably all you need is some type of concordance study between these type of different assays, right? Whereas if you're developing a completely new biomarker that informs treatment decisions and will ultimately result in a patient being prescribed a new treatment, well, then what we think is you have to provide more, and probably there are many situations where you have to do actual prospective trials. And on this continuum between analytical studies, prospective trials, we try to provide guidance and categorize basically the need for evidence of these biomarkers.
With this framework, we hope to bring more AI-based biomarkers from proof of concept into clinics. And also for that, what's needed for the AI models who have enough performance is to increase the trust of the medical community. And the trust of the medical community will be increased if we have clear rules and actual validity of the AI biomarkers. How we could improve maybe in the future these frameworks, which today is variant 1, but tomorrow we will have the version 2, it will be by, for instance, let's think outside the box. Today we have the human in the loop to check and to validate these findings. But maybe tomorrow, if we have 2 or 3 AI models that are predicting the same variable and they were trained on different data sets, maybe this could be considered the new ground truth if all agreed between them. Then we have to establish what's the acceptable performance for an AI-based biomarkers to actually go to clinics. And then also we have to think more, once these biomarkers are validated and used in routine, how do we monitor post-validation to intercept and prevent any possible data drifts?
What we are seeing is that the technology is evolving very fast. We approached EBAI with the premise of having systems that human specialists use to make a better decision. But what we are seeing now out there is that many AI systems are coming out, and there's increasingly claims that they can operate autonomously without human supervision or just a little bit of supervision. And we think that in this changing technological landscape, we have to continue to provide guidance, because this is going to become much more complicated in the future, right? Our duty is to do this for our patients, because our patients want this. Our patients come to us and ask us, why don't you do this AI on my tumor tissue to find out which treatment is best for me? So patients, in our experience, want AI-based biomarkers, and we have to be able to deliver these to them with a quality like any other aspect of oncology care.